Hi, this is Karen O'Brien, and I had a couple of questions coming in this week about how to develop um, rainfall runoff data using SCS. So I'm getting more solar sites modeled and more wind sites modeled, and any kind of site that uses maybe like a curve number as your rainfall runoff, your curve number and your SCS data. So this is how to get some of that data and convert it into to use for FLO-2D. So I have this, the first question I had was how to build this table for an SCS type 3. So I had the type 2 in here, but I didn't have the type 3. So I got this data online from either the TR55 or the HEC. The HEC Center will have this data, the TR55 and HydroCAD. HydroCAD has a whole bunch of different kinds of rainfall distribution curves. So you can get that data from anywhere and basically just use it to build a table. And the table is very simple. It's just time on the left, space or tab delimited, it doesn't matter, and then the percent total of the rainfall on the right. So the important thing is that this goes from 0 to 1, and it takes that as the rainfall distribution curve. And then I'm just save that into a text file using Notepad or Notepad++ or whatever you want to do. And then FLO-2D can read that data into its distribution curve. So if I came to the FLO-2D plugin and I opened up the rain editor, I would use this as my total storm rainfall, and I would use this as my distribution curve. So this total storm rainfall for this area is probably closer to like maybe 3 inches for the 100-year event. And that, of course, you're going to grab from, NexRad or no, sorry, not NexRad, but NOAA Atlas 14 will have that information. And I think for Arizona, the Department of Transportation has a really excellent hydrology manual, or your county will have your hydrology manual for your area. So you can grab your rainfall, your total rainfall in inches, and then open the button right here and load the distribution curve either from the one that you created or from the others that I distribute. And then you can just click open and you can see that that will be, whoops, sorry, I have to check it and select it. That will be applied as my distribution curve so long as it's in this dialog right here. So that's rainfall distribution, very easy to build your own data. Then I found something super awesome. I'm super happy to show you this, and that is this curve number calculator that is available as a plugin. So if you click Manage and Install Plugins and you go to the plugin directory, you'll see here that if you go to All and you search curve number, you'll see here that there is a curve number generator that was developed by Abdul, and he has done something really awesome for us by putting this into QGIS as a plugin. And so we'll show you this plugin. So first of all, you can get the code repository to GitHub, the bug tracker, the homepage, and you can get a training video for this as well. So I'm going to close this, and instead I will go here to the processing toolbox. So again, the processing toolbox is from here, and I just dock it along with the FLO-2D plugin because they're the same size. And you can see that it comes into this processing toolbox. If I double click it, you'll see that I can use my grid layer to set the area to be defined as the area to download the data for, and the coordinate system. And then if I click the sources that I want the land use raster, the impervious raster, the soil vector layer, and then this will be the calculated output layer. And if you don't have, or if you don't like the values that Abdul built directly into the plugin to do the joins and to do the calculation for the end value, you can use your own data. You can use your own lookup table. There is a lookup table in Abdul's plugin directory. I'm sorry, plugin. Yeah, well, let's just call it where the plugin gets installed. So that is this PC. So C drive, users, whatever name you logged into your computer as, that's where your plugins get installed. And then you go to app data. If you can't see this, click view and grab your hidden items, app data, roaming, QGIS. I'm just going to hit the Q button and just follow that into your profile. And you'll see here under Python that your plugins are right here. So here's your FLO-2D plugin. So it's got all the Python code and everything for FLO-2D. And here is the curve number generator, and you can see right here that his lookup table is right here available. So not only can you like access it, you can even edit it and update it if your county uses something slightly different. For example, I think Pima County uses their own software to develop their curve numbers and stuff. So they have PC Hydro that does their own stuff. But I know that one of the things that they do is they don't like to use curve numbers less than 63. So you can see here that there are a couple of areas on our map that would give a lower curve number than 63. But this is, so you can edit this table to make it look however you want and whatever your county or your agency requires. And then let me just minimize this and get out of here, or I can just move it off to the side. I'm going to come over here and I'm going to eliminate these layers that I already did this. So I'll just remove those and get them out of the way. And then I run this calculator and it will add those layers back to the map. So it's going to go online and it's going to download the layers that we want, and it's going to reproject them into our coordinate system and clip them to our project area. So, and I'll close it because it's finished. But before I close it, let me just tell you over here, you have a video tutorial and some extra information about how this plugin works, and a disclaimer that the curve numbers generated for this are a little bit high. So they might, so if you're going to use this, make sure that you check this data and that you or your hydrology team looks this data over and make sure that it's accurate and correct for your project. And then I come over here and I have a couple of different layers that were made. So I'm going to turn some of this stuff off just to simplify my map a little bit. So you can see here that we have the raster for the land use. And as you can see, it is the same size as our project. Of course, rasters always come down as a rectangle with square grids, square pixels with a rectangle of the area. That's just how rasters go. And then we have the raster for the impervious area. And then we have the polygon layer for the soils, which is actually snapped to our grid. So it exactly matches our grid layer. And then this curve number polygon is also exactly snapped to our grid and exactly matches our grid layer. And the curve, then these are the calculated curve numbers. So if you open the attribute table, you'll see that you get your hydrologic group, the MU name, the code, the GD code, which is like a combination of the land use category and the soil code, and then the calculated curve number. It's not really calculated, it's really more it's more based off of a lookup table, but maybe also calculated if there's two zones like that, that split one of the rasters. Okay, so that's the curve number calculator and how the data is. And then for FLO-2D, what we have is this guy right here. So if you come back to FLO-2D, you get your infiltration editor. And first you'll set up your global infiltration. Don't need to really worry about this value here because it will be superseded by the ones that we pull from the calculated layer. And then if you need an initial abstraction, remember your initial abstraction is in addition to your tall value. So whatever your initial abstraction is, subtract the tall off of that before you pop it in here. And then you just click this guy right here to calculate the curve number, and you go and make sure you select the curve number layer and assign the curve number field and click OK, and that will calculate the curve number for your grid. As soon as that's finished, I'll show you where that goes. So that's finished, and I can go down here now to my infiltration layers and turn those back on. And then let me turn these guys off. And what I'll do, let me see. Let me go find these guys. Okay, what I'll do now is I'll take this and I will color it based on a graduated color from the end value, and we can classify that. Okay, so I take the graduated fill, take the curve number of that field, and then classify it and click apply and OK. And you'll see now that your curve numbers are classified like this. So originally my infiltration data came from some polygons. That was a different method of calculating infiltration. This is coming from an external layer. And I've actually had a lot of problems with this. And this system has solved all of the problems I had with getting a good curve number generator and calculating a good curve number from this data. So that's pretty cool. Now let me show you. So that's your curve number being calculated. That's now finished. Now let me show you what I did. So the second question I had is, how do you take your land use data from a raster and convert that into a roughness layer? So I created two things. I created this guy right here that will reclassify this map right here into an end value map using a lookup table. So if I double click on this model, you'll see how it works. So it just takes this data and you just click run, and it converts that data into an end value map, like you can see right here. So my end value for this map, the lowest end value in black is 0.03. That's your golf course and things like that. 0.07 is this kind of full gray area. And then the whites are 0.12 for heavily populated, densely populated areas. And now I can use this raster along with a new tool that I created in the Grid Tools widget to calculate end values from a raster. So if you click this new button, and you'll need to get the latest plugin to do this, and I will link that in the description of the YouTube video. And so here's your source layer. It's just like the elevation calculator. It's the exact same calculator. So you set your source data and you click OK, and it's going to sample the new end value by warping this into a raster that is exactly perfectly aligned to your grid, and it's going to warp the data using an averaging method. So it's an area weighted average from these pixels to the grid pixels. And these pixels are, let's see, what's the height? Looks like these that's the dimensions. What's the pixel size? I know it's in here, I'm just not seeing it. Nope, I'm not seeing the pixel size. I'm just kidding. Oh, here we go. Sorry, these pixels are 30 by 30, which is funny because my grid size is also 30 by 30. So, and that is these pixels are 30 by 30 from this source raster, from this NLDC source raster, NLCD source raster. Okay. So now I have already calculated this. Now just bear in mind one very important thing. All of these data are scratch layers. So as soon as you close the map, they're gone. So if you want to save these, you might want to export them. And I don't know exactly how this works, but yeah, you can export it as a geo package or a whatever. You might need to do them individually because you'll lose them because they save as scratch layers. So let's group them. And I will call this SCS data. And now let me give you a brief overview of how I created this processing tool. And then I think we're finished. Yeah, because, okay, oh, also let me show you one more thing. Sorry, I forgot to show you one thing. So here's the new the new end value data. You can see here, and here is the roadway that didn't get picked up by that land use data. So if you wanted to add roadways, you could download the street polygon layer and you could paste it into this roughness group, and you could use the street polygon layer or the parking lot polygon layer to enhance your map by adding a little bit of urban detail to it. So for example, then I'll show you this street right quick. You can see here that, let me turn off the infiltration layers. You can see here that that street goes straight across the project. And so if I wanted to update that particular layer, I could go into the FLO-2D original end value calculator, update only the roughness polygons, and click the centroid point sample, click OK, and that will sample the end value, a new end value from that layer. So if I go in here and click now, you'll see that, whoops, that the new end values for those cells are 0.035. Now let's take a quick look at how I developed this processing tool to reclassify this data, because it was actually pretty easy. So this is, I'm gonna right click on this, I'm click edit the model. So what you have over on this model is parameters, so inputs, and you can like search these parameters, or you can just go back and you know, scroll through them to get what you want. And I knew that my input layer had to be a raster layer. So then when you get to what you want, you just drag it onto the thing and you name it. So land use raster, it is a mandatory layer. I don't have anything advanced on it, so I'll just click OK. And then, well, let's see, where did it go? Oops, I didn't mean to do that. Get back up to that data. I think it just probably just when I pulled it on there. No, I don't know why it didn't add it. Let's just name it. Oh, it's because I gave it the exact same name. That's why. Yeah, okay, it's because I gave it the exact same name. Or then if you do something wrong or you want to try that again, just delete it. And then I had to get a processing algorithm. This is the one you can reclassify. So this is a standard GIS processing layer or processing algorithm. So again, you just drag it and drop it onto here, and then you double click it to set it up. So reclassify by table is its name. Its input method is to grab that model input. That's important. And then this will be connected to the algorithm, as you can see through this little connector guy right here. And then there's only ever one band in this data, so you don't have to worry about this. That's default. And then this is my output. Now we know it's a raster output. That's the only thing that you can output to, but you can set that up. That this is a model output, but you can also like if you, I'm gonna click OK. If you double click on it, you can make it like save it to a specific location, so it's not a scratch layer. But scratch layers are easy to deal with because you can always just export them as a layer. Okay, so let's get to the kind of the meat and potatoes of this guy, and that is this table right here. So this table, this is super important. So the table is, I just added 20 rows, and then I got from, again, going back to, I think HMS or HydroCAD or any of these other tools that use this kind of data. Actually, I don't think HydroCAD, I don't know if HydroCAD uses it or not, but I know that like the RAS mapping tool uses it, and it's online, available on all kinds of land use categories with an N value. And I have a couple of other tables that you can use to help you build this as well. And so I'll show them to you. So first of all, I got the tables from one online source, and I'm going to grab my tables that I built so you can see how easy they are to build. Let me see, documentation. And I've got one here that has just the land use category and then the minimum N value. And I think there was a min, mean, and a max. And I think this is the max table right here. I should put that in here as max. And these are just comma separated value lookup tables, CSV lookup tables. And then this is like the one with the descriptions, which you do not need. Yeah, here's where I put the mean in. Okay, and I just used the min on these tables. And I just took this table, I took this side and popped it into the lookup table for this guy. So there's only one category. There's no like range of values because these are categories, not ranges. Okay, so your min and max are the same, and that should match over here. Let me cancel out of this. That should match these guys right here, those values. Okay, and let me get back in there. And then these are the N values that came from the lookup table that I pulled off of the internet. So in addition to that lookup table, I also have an entire training series on MappingManners that is, let me grab it real quick. I had it open and then I moved. Oh, here it is. It's right here. Awesome. So you can see here that I have these FLO-2D standard land surface characterization classes for, let me wait for that to open, for the green and amped, but it also has N value for some of these. And this is urban. So I think this comes from the flood control district of Maricopa County. They also have, in addition to this, they also have a Manning's N value for channels and floodplains. And they have some information on MappingManners stuff in their technical support documents. And Jim has a shallow flow roughness and tall white paper. And all of this is, you can get to all of this from my training package that's on my website, FLO-2D.com/training packages. And it's called MappingManners. So you can grab these values out of this table and put them into this table, or whatever values you think you want to use based on, you know, your agency that you're working for or your county that you're working with. The key to this is to click this OK button before you exit out of this table. So you click OK here and then you click OK here. Otherwise, they'll just disappear. And then to run it, you just, I'm going to discard this. I don't want to mess anything up. You just double click it, grab that land cover, click run, and it will just it's just going to reclassify that data. That's all it does. Okay, so that's how you do your N values from a raster. And I will put the link to the latest plugin, which is this stuff. I just did this stuff like yesterday. And I will put this new model as a link with all my other processing models that are in shapefile. So all that will be linked on the YouTube video in the description. Okay, so that's it. Thank you for watching this video, and I hope this helps you.